Have you ever imagined how much you can buy a house? If you are planning to buy a house in the future, what is the price? Today I'm going to talk about the house prices prediction in Taiwan. I'm going to talk about how I selected the data, what sources, and the results I found. And I'll tell you my discussion and conclusion at the end. So first, the data was collected from macroeconomics dataset from national statistics. And I selected variables from several categories. So the variables include year. Year is from 2011 to 2020. And we must have the house price index. The house price index is an index to show the general idea about the price for one floor. And I selected 4 categories, which is the national income, finance, construction, and family income and expenditure. From those categories, I selected economic growth rate, CPI. CPI stands for the prices you spend on goods, the total prices you spend on goods. Bank interest rate, issued floor area. Issued floor area is the total area that government allows the companies to construct. And construction cost stands for the total construction cost. Household saving rate and home ownership rate. It means how many percentage of homes that are owner occupied. So I selected the data from the government and the variables are explained. Let me tell you my results. So the results are divided into 3 parts. The first plot is the plot, some time series plot. And then I will have the relationship between the house price index and other variables. And at last, I will have linear regression to predict the house price index. So first, the house price index, we can view from the graph that it is gradually increased during the 10 years. And consumer price index, the CPI, as well. They both increased during the 10 years. In the meanwhile, the issue floor area and construction cost fluctuated during the years. It goes up and down and goes up again. And the last 5 years. And I can assume that the construction cost is influenced by the issue floor area. If we can build more area, the construction cost would be higher. And household saving rate remains steady and increased a little. However, the bank interest rate decreased during the years. And the economic growth rate and home ownership rate fluctuated and have similar trends during the years. And interestingly, the economic growth rate is 1 year delay than the home ownership rate trend. It means when the home ownership rate at 2016, it went up to the peak, and economic growth rate, it went up to the peak at 2017. It is 1 year delay. So I've told you about all the time series plots. Some goes up, some goes down, and some follow a similar trend. Then let's talk about the relationship between variables. I draw a scatter plot for every two variables. For example, we have house price index plus the home ownership rate. And the relationship shown in red is negative 0.43. So the relationship is not strong and negative. So I draw the scatter plot and draw all the R, Pearson R on the top in red. So as we want to predict the house price index, we have to find the strongest relationship to predict the house price index. And we found that the CPI, household saving rate, and bank interest rate have the strongest relationship with house price index. So we are going to use those three variables to predict house price index. Then I use R to create the relationship to create linear model. So here I create the first three line code is about the simple linear regression. I use CPI, household saving rate, and bank interest rate to predict house price index. And then last one is an multiple linear regression. I use the three variables to predict the house price index. So now we have four models to predict the house price index. But we only want the best one. We only want one to predict the house price. So then I use model selection to pick the best one. And we can see the weight and the last column. Model CPI had a weight of 0.96. It means it is the best. It accounts for 96%. So we can say that model CPI is the best model. The CPI is the best one to predict the house prices. So let's call the function of model CPI, and we can see the coefficient and the slope. So the line is look like this. House price index equals negative 947 plus 12.31 multiplied by CPI. And we draw a blue line to show the equation. So for example, if we know this year's CPI is 100, then we can predict that the house price index is 284. So the conclusion, the discussion is that the finding is that first, we found that there are some similar trends for several variables during the years. And we found that the CPI, household saving rate, and bank interest rate have the strongest relationship with the house price index. And at last, we use linear model to predict the house price index, and we found that using the model selection, the CPI is the best model for predicting the house prices. And last, we form an equation for the prediction line. It is house price index equals negative 947 plus 12 multiplied by CPI. So the conclusion is that using the data and programming language, we get a deeper understanding about the house prices index. And as there are more and more a good number of factors that can influence house prices, further studies are needed to gain a more precise view on the prediction of house prices. Although we give you a conclusion and equation, there's still some limitation. First, we only use 10 years data. And second, as the real world is too complicated and chaotic, the house prices are not easily to predict using linear model. Third, we only use 9 variables to predict the house prices. It might be inadequate to form concrete conclusion. House prices is really important to us. We have to spend a good deal of money on buying houses. Owning a real estate is not as easy to buy clothes. So if we can predict the house price, it might be helpful. Thank you.